So we are going to start, this first video is going to be talking about number 1, which is making a linear regression line of some information using our calculator. So we're going to make a line of best fit of the lung cancer rates, which are Y, which are these values here, given the years, which are X's. And so we're going to start this process by going to Stat, and we're going to edit two lists. And so I have my list 1 and my list 2. So I'm going to edit the years for my list 1, which starts in 1999. Oops, 1999, and then it goes up every year. So we have the year 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007. And I think that's where it stops. So I'm going to move over to list number 2. And in 1999, it was 93.5. So that's 93.5 deaths to lung cancer per 100,000 people. And so then it went down to 91.5 the following year, and then 91 even. I don't know how they get the 0.5. It must be an average. 89.7. And then 89.3. This is actual information, though, by the way. 87.8, 87.8. So we must be taking better care of ourselves because it is going down, which is great. 84.2, and then 80.5. So now what I want to do is put this information and make a scatter plot. And so right now, if I go to graph, nothing happens because my y equals, there's nothing lit up. And so I want to turn the plot on. And the way we turn the plot on is we go to second, y equals. And you can see they're all off right now. So what I want to do is go to number 1. I'm going to click enter. And it's off, but I want to make it on. So I'm just going to put my cursor over the on and click enter. It's a scatter plot, which is what I want. My x values are in list 1. My y values are in list 2. And I'm going to use, I like the little plus signs. So that's what I'm going to use here. And again, if I press graph, nothing happens. And that's because my window is not what I want it to be. I'm going to have my x values. Remember, my x values are the years. So I'm going to have my x values start in the year, let's say 1995. Oops, 1995. And I'm going to go to the year, let's say 2010. And I'm going to count by 1 years. That's the scale. Then my y minimum, my y values start at as low as 80.5 and go up to 93.5. So I'm going to start maybe at, let's go 75 to maybe 85. And I'm going to make my scale 1. And so now when I graph it, I should graph, my plot 1 is on. You can see I have 3 plots there. This is highlighted, so that means it's on. I'm going to graph it. And let's see what happened here. Let me change my window. I went from 75 to 85, and I didn't go high enough, so I need to make this 95 here. So I'm going to go down to 95, and now when I press graph, it's going to show me more points. So you can see that it is going down pretty steadily over those years. So then what I want to do is make a linear equation so I can make some predictions about lung cancer in the future. And so I'm going to go back to the same button that I started with. I'm going to press the stat button. I was on edit and edit, but now I want to calculate a linear regression line. So I'm going to go over to calculate and press enter. I pressed 2 things, so I'm going to start over. I'm going to go to stats, I'm going to go to calculate and press enter. Let me try that again. I'm going to go to stat, calculate. Okay, so this is what I was doing wrong. I need to go down to the linear regression line. So I'm going to go down, instead of 1 variable stats, I'm going to go to linear regression line and press enter. And so now if you have a TI-84, this is where it gets a little bit different, but their calculator is wanting the same information. The first thing that it wants to know is where do the x values come from? So my x values come from list 1. So I'm going to go to second list 1 and then put a comma in there if you have a TI-83. Then, if you have a TI-84, there's a window here. They're asking you several questions. Then they want to know where do the y values come from? Well, the y values come from list 2. So I'm going to go to second list 2. There's the list 2 right here above the 2. And I'm going to put a comma in there. Now, this next part is not necessary, but it's really helpful because you're going to store this equation that your calculator is going to give you in your equation grapher. And so you want to put y sub 1 in there. And if you have a TI-84, it's the store EQ something. I forget what it is exactly. But I'm going to go back to, I'm going to go to vars, variables. Y sub 1 is a variable. It's a y variable. And I'm putting in a function. And I want it to be y sub 1. And so now when I press enter, this equation right here gives me the equation for the amount of lung cancer deaths as they go down each year. You can see the slope is negative, which is good. Looks like the y-intercept would be 2,912, which wasn't so good. Maybe back in the year 0 if this trend continued backwards that far. I could go ahead and graph this. You can see it kind of hits those points fairly well. Looks like there's maybe more of a curve here than what my line is showing, but it's a pretty good model of what's going on. And so then I have used my equation to answer some questions. So I would type my equation, which is right here. I would put that equation on the line, and then it says use your equation to predict the lung cancer rate per 100,000 people for the year 2025. Well, I can go ahead and plug in 2025 for X into my equation and just do it as I normally would. But the nice thing with a calculator, because I have this in here, now I can just go to second and table, and I could scroll all the way down to the year 2025, but that's going to take a while. So I want to go to table set, which is second window, and this is something that I really haven't shown you in class, but I want my table to start maybe in the year 2020. And now if I go back to second and table, you can see it starts in the year 2020, but in the year 2025, there's going to be 57.213 deaths based on my model in the year 2025. So that's what would be here. The second question, that's what would be here. The second question is, when will the cancer rate for 100,000 people be down to 50 people? Well, I could use my equation and set it equal to 50 and solve my equation. Or with a graphing calculator, especially if I'm in a table, I'm this close to 50 right now, looks like it's going to be right around the year 2030. So in the year 2030, we're going to be down to about 50 deaths due to lung cancer per 100,000 people. Hope this makes sense. This is the major concept for what we're trying to do here. We're going to build upon this concept all year so that we're not going to just be doing linear models, but we're going to be doing quadratic models, cubic models, all kinds of different models based on data that we have. So this is question number 1.